Hello everyone. In this lesson, we will be focusing on search rationalizing. A key inquiry question is how to rationalize the denominator surd by multiplying with another surd. As we have learned in the previous lesson, surd is an irrational number that's written in square root format. Rationalizing means it's converting a surd into a rational number, removing the square root sign. Let's look at it in much more detail. Before starting this lesson, I want to focus on five key questions which some of the pupils had issues with. First one, what is square root 5 times square root 3? As they both the surds, 5 times 3, which gives us square root 15. What is 2 square root 5 plus 3 square root 5? It's compared to normal algebraic simplification, which would be 2 lots of x plus 3 lots of x, which gives you 5 lots of x. In this case, it's 5 square root 5. Some of the students have added square root 5 plus square root 5, giving us square root 10, which is incorrect. So the answer is 5 square root 5. Next, focusing on simplification of surd. Square root 45 can be broken down into square root 9 times square root 5, which would give us 3 square root 5, because square root 9 is 3. Finally, how would you simplify square root 50? Take away square root 18. What some of the pupils have done is subtract 18 from 50 and have square root 32, which are further simplified, which is incorrect. First, you need to simplify the surd, can be written as 25 times 2, which can be further square rooted. Hence, this can be simplified into 5 square root 2. Square root 18 can be written as 9 times square root 9 times square root 2, which can be further simplified as 3 square root 2. Hence, 5 square root 2, take away 3 square root 2, which gives us 2 square root 2. Before we look at an example of rationalizing the denominator, let's briefly recap what's a rational and irrational number are. A rational number can be expressed as a fraction, 7, half, 0.3 recurring, which can be expressed as a fraction, 1 over 3. An irrational number cannot be expressed as a fraction, square root 2, which would give us 1.414, and the decimal place is continuous without any recurrence or pattern. Let's look at a fraction. The numerator is a rational number and the denominator is an irrational number. Let's look at a first example. Rationalize the denominator. We have 5 over square root 2. It can be rationalized by multiplying the denominator square root 2 on both sides, which we get 5 square root 2 over square root 4, because 2 times 2, which gives you square root 4, and square root 4 can be converted into a rational number because square root 4 is 2. Similarly, 12 over square root 5. We can multiply by square root 5, which is the denominator, on the numerator as well as the denominator, which gives us 12 square root 5. Notice I haven't multiplied 12 by 5 because 12 is a rational number and square root of 5 is a third or irrational number. Square root of 5 times square root of 5 is square root of 25, which can be further simplified as 12 square root of 5 over 5. Using these two examples, please rationalize the denominator 4 over square root 7. Press pause and attempt the question on a piece of paper on the exercise book. Once completed, press play to check your answer. Press pause now. Here is your answer, 4 square root 7 over 7. Let's look at another example, 8 over 3 square root 2. Notice I multiplied only by square root 2 on the numerator as well as the denominator, not 3 square root 2, because 3 is a rational number and square root 2 is an irrational number. I'm trying to only rationalize the rational number, which gives us 8 square root 2 over 3 square root 4. We know square root 4 is 2. 3 multiplied by 2 gives you 6. This can be further simplified by dividing it by 2. Gives us 4 square root 2 over 3. Using this as an example, please attempt this question. Press pause now, attempt the question. Once completed, press play. Here's the answer. Make sure you multiply only by square root 5 on the numerator as well as the denominator, which gives us 5 square root 5 over 3 times 5, which is 15. I further simplify the fraction by dividing it by 5 on both sides, which gives us square root 5 over 3. Now let's look at rationalize the denominator, which involves more than one term. Notice here we want to rationalize square root 2 plus 1 over square root 2 plus 2. I want to convert square root 2. I can't multiply just by square root 2 because the denominator will still have irrational number or a third. So firstly, I find the opposite pair of square root 2 plus 2. Opposite pair of square root 2 plus 2 is square root 2 minus 2. This could be considered as a plus b, and the opposite pair is a minus b. So multiply the numerator and the denominator by a minus b, which gives us square root 2 plus 1 multiplied by square root 2 minus 2 over square root 2 plus 2 multiplied by square root 2 minus 2. Expanding them gives us 2 plus square root 2 minus 2 square root 2 minus 2 over 2 plus square root 2 minus 2 square root 2 minus 4. Now, this could be further simplified to take away 2 would give us 0. 1 lot of square root 2 take away 2 lots of square root 2 gives us minus square root 2. Or you could represent them as algebraic terms, just 1x minus 2x, which gives us minus x, over 2 take away 4 is minus 2, 2 square root 2 minus 2 square root 2 cancels each other. Multiplying and dividing by minus 1 on both sides will give us square root 2 over 2. Notice now we have rationalized the denominator. Using the examples provided in the video and also in the slide, please open the worksheet rationalizing the denominator. The questions are provided on the left-hand side. Make sure you show you're working out clearly and your answers. Ensure you simplify the set and also simplify the fraction. The extension questions are provided below. The questions involving a single expression on the denominator are grade 6. Questions involving multiple expressions on the denominator are grade 7. And the extension questions are of grade 8. Once completed, please attach the completed worksheet to the assignment. I repeat, the completed worksheet, not a worksheet which is empty. Good luck.